Our speaker today is David Huntley. David is a research associate who oversees the maintenance and construction of our DEOS network and all of its sensors. David has been with CEMA for about 11 years. He's held a number of other technical positions prior to joining CEMA, including serving on a submarine in the United States Navy. And he also brings a wealth of technical knowledge and experience to our team. So at this point, I'll turn it over to David, who will be presenting on developing and maintaining the DEOS network. David?
Thank you very much. Hi, so I'm Dave Huntley. As Kevin said, I've been with DEOS now for about 11 years. It only took me 2 tries to get here. I had tried earlier around 2007, but number 2 on the list. These things happen. I have been in a lot of industries before I got here. I've been in the automotive industry, agriculture, oceanography, not to mention submarines. So I come at this from a bit of a different perspective, I think. So where are we? So here in Delaware, we're the tiny little state over here with that big bay to our east. We have 56 meteorological stations and 40 pond stations. On the left, you can see all of our MET stations, and on the right there, that image shows all of our stations. That's both MET stations and water stations. Our whole network is about 110 miles from north to south, and at the widest point, it is 35 miles wide. What kinds of stations do we have? Well, we have various platforms. So we have tripods, not many, but a couple. We have pond stations. Those are on mill ponds. We have beach stations. We have agricultural stations, and a couple at airports. There's that picture in the upper right is the Laurel Airport. Then the Bethany Beach Boardwalk is next to it. I don't remember which pond that is off the top of my head. I think that actually might be Beck's Pond. And that's in the Tabor Forest on the left. Georgetown is our 10-meter tower. We'll be updating a couple of stations in the future to 10-meter towers. That's a big agricultural site. It's also an older site we adopted several years back. So our growth has been sort of fits and starts. The green lines there represent total number of stations. The blue lines represent our MET stations, and the orange are our pond or water stations. So back in 2004, they started with one station, Porter Reservoir. And then they started adding a few stations here and there, Bethany Beach, Newark, Hockessin, places like that. And then in 2006, the snow monitoring started. And then Kevin joined DEOS, and you can see the growth starts there. About every year to 2 years, they added more snow stations or boardwalk stations. 2008, 2009, 2010, those are all sort of, there's added growth each time. I joined in 2013, and in 2014, we added snow sensors so that we had 3 snow sensors in every, at least 2, but in many cases 3, in every snow maintenance area that we have in the state of Delaware. So that increased our MET stations up to 56. In 2015, we started with the ponds. So we had a single pond station in 2014, and then we started adding 5 per year for the next 8 years, and we are now at 96 stations. We will be next year, hopefully, if things go right, we'll be adding 8 more stations. Those are fish and wildlife impoundment stations, so they're water level stations, and that'll bring us over 100 stations. Siting. So a really well-sited station has lots of open space. You can see that Georgetown site, it's wide open. There's cornfields, and there are cornfields to 2 sides. There's an open space to one side. There's a short, full, like a poultry house behind us in this picture. It's not very tall. It's about less than a story tall. So it doesn't really impact winds in this area. And it's a pretty well-sited site. But early on, there were some mistakes. Now, this isn't really a mistake. I mean, there are mistakes here, but this was they were looking for a site at the airport, and the airport management said you could put it here in this corner. And at the time, the mitigating circumstance was communications. So these sites either had line of sight radios, which a short haul radio, if you can't see the receiver, you can't talk to it. So it had to be close, or at least an unimpeded view of the receiving station, or you wired it with a like a Cat3 cable, and you could only be about 200 feet away from the building where the modem was. So there used to be a building very close to this station. And then, of course, that fuel truck wasn't there way back when they first put it in. The airport moved it there and said, oh, it'll be temporary. This picture was taken just before we moved that station. So about 10 years after the station was installed. The fuel truck never moved during that whole period. So that particular site is actually, it's the site in the upper right-hand corner here. That's where we moved it to. It's a much better site. So every once in a while, people let us put things in weird places. So that's one of them. Things change as time goes on. This site we put in 2014. This was the first station I put in. And when we put it in, that was a grassland. On the upper left, in 2 years after we put it in, you can see that they didn't mow. They didn't keep it trimmed back as a meadow like they said they were going to. And you see the red pine starting to grow. And 18 months later, in September 2017, the trees, those red pines, are now about 10 feet tall. They're almost as tall as the station. And they hadn't mown close to the station other than that little lollipop and trimmed everything back for us. So we asked them to go 100 feet back, and they did. And now 2022, 5 years later, those red pines are over 30 feet tall and they are dense. And so this site, the winds here were pretty bad because it's we didn't get any wind. There was one space we get winds. There's a hole to the bay behind us, and you'd get wind from there. Everywhere else, you wouldn't get any wind. So we were talking about abandoning the site, and then somebody vandalized the site, knocked it down. And so we have since moved this or removed this and abandoned that site. It's no longer there. That was last year. Some sites offer specific challenges. This is our Indian River facility. It's actually on the sand dune. And the sand dune moves. So if you don't know how much a sand dune can move, over the years, you can see that gentleman who is standing there, his name is Sean Hudson. He was our former grad student. He's 6'4". So at one point, that enclosure was 9 feet off the sand, and the top of the osprey pole was 24 feet up. A couple of years later, the sand had moved in, the dune had started to reassert itself, and the enclosure was about 7 feet off the ground. The picture in the lower left-hand corner, the dune has continued to come in, and as you can see, everything's sort of moved up a little bit. That the enclosure is now about 5 feet off the ground. I'm a pretty short guy, and I can stand on the sand and work on the box at this point. Now, 2 weeks ago, we had a little bit of a coastal storm, and you can see that the beach broke through, the ocean broke through the dune line there and flooded the street. And that is the Route 1 just south of the Indian River Bridge. It's about a quarter of a mile south of our station. So it's entirely possible the next time I get to Indian River, I'm going to be back to that first picture there where the enclosure is 9 or 10 feet away from the sand. So this site moves a lot. And then you have other problems. So the site on the left, the picture on the left, is our Nassau site. That site we put up, and about 2 months later, we had a windstorm, and it blew that bleacher set directly into the station, and it broke everything on the station except the tipping bucket. It completely flattened it, and we had asked the school if they had secured their bleachers. They said, "Oh yeah, of course we did." Well, we had that wind gust at the time. We didn't have any wind measurement device on that particular site. We do now, but they've also anchored all of their bleachers. So that was 2 months, a lot of work, and we put 2 stations there in that 2 months. On the right I'm not 100% sure how they managed this. This is actually at the police station. It must have been the mower because the Department of Corrections does the mowing at this facility. And they really must have not liked the station because they hit it so hard, they took all of the conduit out of the ground. So that site has also since been moved to a slightly better location. Then you get critters. So you can have bad relative humidity readings if you have something like a mud dauber on top of your HMP 45. As that mud starts to dry, you get an elevated RH values. Then you have the, of course, the guardians of the galaxy here. We have those bald-faced hornets. You get the little tiny ones. They're not so bad. 2 weeks ago, or about 3 weeks ago now, our technician came across that lovely 3,000 bald-faced hornet nest on the back of the solar panel at one of our pond stations. I'm not touching that until we have at least 3 days of really frozen weather. And sometimes you get lots of weeds. So this site is our bucktoe site. It's a research site for other things. They do ornithology research and crop research and a bunch of forestry stuff. But what you're seeing here is mostly milkweed and mile-a-minute weed. And for those of you in the South, mile-a-minute weed is like kudzu. It grows super fast and over everything. This is a site that they have since introduced a biological control for the mile-a-minute weed. It's a leaf miner, and it eats the leaves until they look like Swiss cheese, and the plant can't grow as well. So they have actually really controlled the mile-a-minute weed now, and they've taken that fence down, thank you for us. But this site always has been trouble to maintain. When the mile-a-minute weed was going completely rampant, we would get mile-a-minute weed all the way up to the top of the wind sensor. And then it would be like 3 hours of weed clearing just to find the station. This is our Rehoboth Beach station before we moved it. And sorry, Bethany Beach before we moved it. But when we had updated it, you get corrosion at these sites. Beaches are really difficult to deal with. You can see that in the bottom middle picture there, the pipe is corroded, the bracket is corroded, it's pulling away. The same goes with the middle picture. Those are dissimilar metal problems where you have galvanized steel and then stainless steel, and then you have copper arsenate. That's what they pressure treat the lumber with. And so and then the screws holding the bracket on in the bottom picture, they're aluminum. You get all those dissimilar metals, and all of that stuff starts to rot away over time, and it causes electrolysis and other problems can occur. Your cables get brittle because of the electrolysis, and it's pretty amazing. But then you also have some material selection problems. That top middle picture there, when we replaced the enclosure, we used to get the enclosures and they would come with all stainless steel components, and I didn't check this one. And when we installed it, that was a brand new box. That's only been, that picture with that rust on there is less than 6 months. That bolt was common steel. It should have been stainless steel to match the bracket behind it. And so what happens is that when you put stainless steel and common steel together, the common steel loses it oxidizes faster and it swells. And as it's full, as it's swelled up like that, you can see where it broke the enclosure. There's that crack. It starts here and runs down below the bolt. That crack is because of the common steel corroding. And then over here on the right, this is a wind sensor, a marine wind sensor, and this is a misguided attempt, I think, to make removal of the sensor more convenient. That is what everybody calls a mil-spec connector, and the problem is that the common perception is that mil-spec means it's good. Mil-spec just means the cheapest person built it and they decided that they're going to stick with it. And so that particular device is that mil-spec connector is terrible. That was designed in World War II, and they've used it ever since because it's cheap to make. It's potted aluminum, and you can see the line in the middle of there where it fractured. So I think the lock springs are there's like these little C-clips. They're made out of stainless steel, and then the aluminum, and then the pins are gold covered. I think it's gold covered copper or gold covered stainless. But you get electrolysis inside there, and that swells and breaks. This is also a problem with the new CS301s. They 12 inches away from the sensor, they put those little clips on there, and I cover them with adhesive filled shrink tube just to keep the corrosion at bay. I would much rather they didn't have them at all. I'd rather replace the entire sensor with its cable than have to deal with those silly little connectors that I don't like. What kind of sensors are we talking here? So we have precipitation gauge. That's a tipping bucket in the upper left-hand corner. The next two are both relative humidity and temperature sensors. And actually, there's another one. The EE181 over here is a relative humidity and temperature sensor. And the middle picture at the top, that was a test sensor that Campbell sent us, asking us to put it somewhere really rough, and we put that down at the beach. And that's about a year and a half at the beach without changing it out. And you can see that the coupling has completely corroded away. It's caused swelling inside the enclosure there, and there's a crack right along that edge there from all the dissimilar metals. I'm hoping that gets changed. That's a bit of a weak point on that sensor. Then we have barometers up here inside the box. That's our data logger, our solar power. That's the charge controller, our cellular modem. This is a net radiometer cable. Then we have a pyranometer up here in the left that does solar insolation, so the amount of sunlight that comes in. And down on the right-hand side here, we have snow sensors. I was just showing you that that says 2847 and 14,469. Those serial numbers are, our oldest one was 1295. So we've been doing snow sensors for a long time. If our latest one was 14,000 and our earliest one was 1200. So, and then our wind sensors, this is wind speed and direction. And we also put these out because the red-tailed hawk really likes it. So that guy actually stayed there the entire time I was doing service on the station. He just watched me. And I was like, oh, that's our biggest raptor in the area. They're humongous. And then we have volumetric water content in the soil as well as soil temperature. That's a CS616 over here in the corner. So all of these sensors have to be calibrated. So we have a calibration schedule based primarily on the data that as we see it. We have started this after I joined. But our temperature relative humidity sensors are every 2 years. Pyranometers also 2 years. Our barometers don't seem to have a lot of drift to them. We don't notice it. We have a lot of barometers. We have about 31 barometers out of 100 stations. So for our small area, that's a lot of barometers, but every 5 years we do the barometers. Our wind monitors have a split calibration. The nose cone bearings get replaced every 2.5 years, and the vertical bearings every 5 years, along with the full calibration. That's really out of an abundance of caution. We noticed that between 2.5 and 3 years, the wind monitor nose cone bearings either get noisy or they stop working, they break. It's actually less trouble to replace the nose cone bearings than to go out and fix a broken nose cone bearing, because often what happens is the bearing seizes, it spins the propeller then shatters, or it pops out and flies away, and then you lose the shaft, you lose the nose cone bearings. It usually damages the nose cone in the process, and it destroys the propeller, and the propellers are about $200. So I'd rather put $20 in every 2.5 years and fix that, and it's really has prevented us from losing that and replacing the whole sensor all the time. Our snow sensors, so we have 34 snow sensors that we deploy. We used to have we had the SR50 way back when in 2007. Then we had the SR50A for the next 15 years. And we're now starting with the SnowView 10s. And we do an annual renewal of the transducer. It's mostly abundance of caution. Because there's nothing else that's calibratable on those sensors. So rather than like allowing the drift to occur, we just replace the transducer. That's a process. It takes a week to do all of the sensors here, and we do it all of it right in-house. Then we do our annual calibration check of the tipping bucket, and if you can't calibrate it, we replace the entire mechanism. And then our shop, back in 2014, that's where we start. We started down here in our new shop, and that's how much stuff we had in there. And then today we have a little bit more stuff. And then our trucks, the one we just retired, the old 2011 here with 170,000 miles on it. The transmission finally gave out. There's our new truck, and we have an Equinox. How do we keep track of this stuff? All of our tickets. This is our field app. Chris is going to really go into this a little bit more so this field app is a real game changer. It allows us to have all of our various kinds of tickets, quarterly maintenance, bond maintenance, trouble tickets. It gives us the priorities. It tells us where they are, what's wrong, what kind of ticket needs to be done, and this is maintained. And my favorite part is the sensor stuff. So I can look at one station, see what's on that station. I can see when it went out. I can see when it was last calibrated and when it's due for calibration. Okay, that's it for me. Is there any questions?
All right. Thanks, Dave. So thanks, Dave, for the excellent presentation. At this time, we'll turn it over to Tina Callahan, who will go through your questions that you posted in the Q&A forum.
Yeah, thanks, Dave. That was great. We did have one question in the Q&A, and I'd like to see, Alex, did you want to just verbally ask that question, or?
Sure.
Okay.
Yeah, so I was just curious. Thank you, by the way, for the presentation. Very good. I was just curious, now that MDEM has now been expanding their mesonet stations across the Eastern Shore, if there's any sort of, collaboration that's gone on between DEOS and MDEM with that or not, or if there's any plans on like expanding your display to also show MDEM data as well, kind of like the New Jersey WeatherNet does.
I think, Kevin, you could take that.
Yeah, Dave, I'll take that one. Yes, the answer is yes. So we are coordinating with the Maryland Mesonet. There was a recent station we're maintaining down in Salisbury, Maryland, Salisbury University, that now is being moved over to their responsibility. They also are placing their weather stations on the Eastern Shore in a configuration so that their stations aren't like right next to ours that are near the Maryland-Delaware border. So we are coordinating in that way. We've certainly provided some advice and things to them in terms of getting their network started. In terms of the data, yeah, we do have plans to coordinate with them. Not just in terms of putting data on the DEOS website, but maybe even extending some of the applications that we've developed, if we can, to use some of their data to make some of these things like the irrigation scheduling system that we have maybe available to other users in Maryland. But that's still a bit ways down the road.
Okay, great. Thank you.
We did have one question relating to how the snow sensors work. Dave, did you have a brief way to explain how that works?
Sure. So the snow sensors are sonic, ultrasonic transducers. So they send out a sound, and using the Doppler shift, you can measure the height underneath it. So essentially, it pings the ground, hits a hard surface, you get a return. It calculates that time. And as that distance changes, the time changes, and you can actually measure height using that. This is a Campbell Scientific sensor. Other companies make similar sensors. The Campbell seems to be really good for us. We've been using it a lot.
Great. And actually, Steph, I don't know if you'd rather unmute yourself to ask the question. I want to make sure you get the right answer that you're looking for.
Sure. Great presentation, Dave. Thank you. Are your Met stations, are you built out in the state of Delaware, just Delaware, or do you plan on adding more Met stations to your network?
So we have a couple of places where we could have we have holes that we could fill if we could find a location for them to put a station. But we're pretty built out. I mean, there are, like I said, there are a couple of holes that we would like to find a spot, but we haven't been able to place, or the locations that are available are not ideal for putting the station.
And when you do add new stations, how are those funded? Do you get those through a DEMA grant, or do you apply for other grants?
Kevin?
Yeah, so we support the network through a number of different funding sources. So certainly the Delaware Emergency Management Agency is one, Delaware Department of Transportation, DENREC, the Delaware Department of Environment and Natural Resources and Control. So those are the main operations and maintenance funders of our network. We also have funding through a program called the National Mesonet Program, which is run by the National Weather Service, that provides some operational support to our DEOS network. So the combination of those resources is how we are able to manage and maintain those stations. At this point, if we were to add more stations to our network, we would be looking for commitments to maintain those stations, as long as possible, because we just don't have the capacity to add more stations without additional support.
Great, thank you.
At this time, I don't see any other questions in the Q&A. Does anybody else have any further questions? Okay, I think that's it.
All right. Thanks, Tina. Thanks, Dave. Of course, if anybody has any questions or thinks of something after this webinar and wants to email us or reach out to us, you can email us anytime at cema-info@udel.edu. And David, if you want to throw the next slide up, then that'll give them the web address, I think, maybe.
Nope, it was on the first one.
It was on the first one. Sorry.
Yep.
Our speaker. So next week we have our second seminar, our webinar in our series. It'll be focused on assuring the data quality of the DEOS network. Our speaker for that webinar will be Chris Hughes. It'll be at the same time as today, Thursday, September 19th at 1 o'clock. If you haven't registered for the webinar yet, you can find the registration link in the original email where we announced the webinar series, or you can email us at our cema-info@udel.edu, and we'll send you a link so you can register for that. With that, thank you for your time and interest today, and hopefully we'll see you next week.